In this lesson, we're going to look at what functions are and how you can use function notation in solving algebra problems. So let's just start right in and ask the question, what is a function? A function is simply a relationship in which the independent variable has one and only one dependent number that goes with it, or value that goes with it. The one-to-one relationship is the important part. A very simple function. If we were to say y is equal to x plus 2, this is certainly a function because the independent variable x, any number we pick, say 4, if we take 4 and add 2 to 4, that will get us 6 and no other answer. So the y value has one and only one value for any value we pick for x. That's the whole key to functions. We can represent functions in quite a few ways. I want to look at a few of them here. We can represent functions as tables. You know, if you see a table that does this, you've got an x value and a y value. It doesn't really matter what I put here. 1, 5, 7. And I can do this. This is 2, 3, 4, and I'm going to put a 4 here also. This table actually represents a function because if you look at the value of -2 and I say if x is equal to -2, what is y? Well, the value of y is 2. It doesn't have but one possible value. If I put what is the value of y if x is 5, then you know the value of y is 4. It has only one y for any given x. Now you notice I put 4 twice over here in the y column. I did that on purpose because I want to point out that that doesn't keep it from being a function, because any value of x can have one y, but it's okay if those y's were the same. So in this case, if I say to you, what is the value of y if x is 7, you would say, oh, well, if x is 7, y is 4. Notice it still only had one y value for the x. Now, if I were to do this, if I were to write another 7 right here and give it a different value, like that, now x has two values for the same x. There are two values of y. In this case, if I said, what is y if x is equal to 7? You would have to tell me it's 4, oh, and it's 2. Now there are two y's for the x's. This is not a function. So one way we can represent them is as tables. If you want to know if the table represents a function, be sure that for all the x's, if there's any x repeating, that it doesn't have two different y values for that. In general, we say the x's shouldn't repeat. It's okay if the y's do. That's true as long as if the x's repeat, the same y doesn't apply to them. Then you won't have a function if the x's repeat, but it's perfectly okay if all the y's were the same number, as long as any x only gets one value for y. A second way that we can represent functions is as a graph. So I can draw this picture here. Probably one of the simplest functions we know is just a linear equation like this one. This is a linear graph. Notice that any point I pick on x, say right here, the value of y is right there, and there's only one value. So this does represent a function. There's a test that we use when looking for functions on graphs. It's called the vertical line test. Vertical line test says as long as anywhere we draw a vertical line on the graph, it will only pass through one point, then that is a function. If there's any place on the graph that you'll go through more than one point, then that one is not a function. So let's just take a look at something here. Erase these. And again, I'm going to draw here. What if I had a graph that looked like that? In that case, if I draw a vertical line through that, the vertical line goes through 2 points. Therefore, that is not a function. So for the vertical line test, to prove that it is a function, there can be no place on the graph where a vertical line could draw through, that you draw could go through more than one point at a time. Third way we can represent functions is one we looked at already, symbolically. We can just write them as an equation, y equals x squared minus 1. Again, no matter what value you pick for x, you will only get one answer for y. So if we say where x equals 2, then we would plug 2 in. 2 squared is 4, 4 minus 1 is 3. Therefore, this is a function, this equation. So we have symbolically represented a function. If you graph the function, it should pass the vertical line test. If you do a table of values, you should only get one value of y for any x that you give. So that would indeed be a function. The last way we represent functions is we actually can do them verbally. I can say to you, you're going to be paid $15 per hour. And if I do that, then you know that in order to figure out your hourly wage, you're going to multiply 15 times x, the number of hours you worked, and you're going to be able to find out exactly how much you're paid. That is a function because there's only one value of y for any value of x, x being the number of hours you work. So I can verbally do a problem. We call them word problems a lot of times, but those can also represent functions. Imagine how confusing it would be if that were not a function. You get paid $15 an hour and it might be this much or it might be some other value. It wouldn't work very well. So those are 4 ways that you represent functions. Let's look at the function notation. We could write symbolically, we could write an equation as y equals x squared plus 3. If we wanted to use function notation, we could write this exactly the same. Instead of writing y, I'm going to write f of x. And that's how we say that, f of x. And all this means is the function evaluated at x, or some value of x, is equal to x squared plus 3. Now the neat part about this is it doesn't have to be an f, it can be any letter. So we can actually name this function, and then we can ask a question like this. We can say, what is f, what is the value of the function f evaluated at 1? Which means what we're really doing is we're substituting 1 right there for x. And so we can say the f of 1 is equal to 1 squared, which is 1 plus 3 is equal to 4. All that really is the same thing as saying y equals. So if you're bothered by f of x, just think it's the same thing as y equals, and you'll be able to do that okay. Now, the nice part about this is if we were going to do the same thing at the top, we would have to write the words where x equals 1 or when x equals 1 so that we would then go back and plug that in to x to find the value of y. By having letters to represent them, f of x, g of x, h of x, we could name several functions and we would immediately know which one we were referring to, as in this example, because it said the f of 1. We would know this goes with the function lettered f, and we could plug it into the f function. So that's what function notation is and how it's used. Invite you to look at some more lessons on functions that I have posted. If you're interested in parent functions, or if you want to know more about domain and range of functions, which are very common topics, there are other lessons on that. You'll find those at MyMathEducation.com. I invite you to go there and look at those. They're organized by lesson there. Also hope you will subscribe to my YouTube channel at MyMathEducation. Thank you for watching this, and I hope you'll come back and watch some more videos. Thanks.